Hi, everybody, and welcome to this session on MLOps done right. I'm so excited to have some presenters with us here today. But before I go ahead and introduce Dave and Kafir, I want to just take some time to introduce myself, thank our sponsors and partners, and then tell you a little bit about how this session will flow. I'm Kathleen Mulch. I'm a managing partner and principal analyst at Cognilytica. We're an AI-focused research, advisory, and education firm. And we have helped put this conference on today. This event wouldn't be possible without the incredible support of our sponsors and partners, including Allegion, Appen, AWS, Carahsoft, Cloud Factory, Databricks, DataRobot, Labelbox, Microsoft, MTX Group, OmniSci, and the fabulous folks at Veritone who are with us here today. This conference is for you, and as we've said throughout the entire conference, we want to make sure that you have as much opportunity to interact with presenters and content providers as possible. All live sessions offer a way to post questions. Below the video, you'll see a section that says Ask a Question. If you click on that Ask a Question button, you'll be able to ask your questions as they pop into your head throughout the event. So that's also a cool feature about this is that you can upvote questions, which we have seen done throughout the conference. So if there's any questions that other people have asked and you want answered or you have a similar question, please go ahead and upvote that and we'll ask it in that order. All questions will be held until the end of the presentation, so I just want to reiterate that, but feel free to continue to ask them as they pop up in the session. The replay video also has a really cool system where when we're answering the question, I can click that we're answering that and it will direct you to that part of the Q&A in the replay. All questions will also be moderated to make sure that they're appropriate and on topic. In the spirit of maintaining maximum interaction between attendees and presenters, these events are held under the Chatham House rule. So that means that anybody who comes to a session is free to use the information from the discussion, but you're not allowed to reveal who made that comment unless you get specific permission from that person. All live sessions like this one are being recorded and they're available for instant replay once the session wraps up. If you have any questions throughout this entire event, we encourage you to check out the FAQ section that can be found at dataaiconf.com. It's a great starting point to get all your questions answered. But now I'd like to introduce both of the speakers before I turn it over to them. So our first speaker is Kafir Yeshayehu. He currently serves as Senior Vice President of Products at Veritone. He's passionate, customer-focused product leader, and he has demonstrated experience in building and delivering AI and cloud products from inception to market. We also have with us Dave Smith, who's a Senior Director for AI and ML Professional Services and the lead AI ML scientist for Figure 8 Federal, based in Washington, D.C. He currently drives Figure 8 Federal's work in Pathfinder AI ML programs in the Defense Department and intelligence community. He has over 25 years of experience, and I know that Kafir also has a very comprehensive background as well. So I'm excited to have both of them with us here today. I'm going to now turn it over to their presentation, and they can go ahead and get started.
Oh, hi, Caitlin, and thank you for having me today. Hi, Dave, and thanks everyone for joining us to this session about machine learning operations. In our session today, Dave and I will cover various best practices for running AI at scale. Our goal today would be to arm you with concepts and ideas that can help you then build and operate robust AI solutions in your organization. We will start with a short overview of the Veritone's AI operating system. We call it aiWARE. We will then dive into specific best practices for machine learning operations, MLOps, all derived from real-world experiences by us in Veritone and by Figure 8 or by our customers. We will then quickly have a quick peek into the evolution, or should I say revolution, driven by low-code AI. And then Dave will take over to discuss the super critical aspect of DataOps as inseparable part of MLOps. Throughout the session, we will draw from experience and lesson learned gathered in Veritone for over 5 years building AI applications and solutions. Now, Veritone is in a quite unique position as it relates to MLOps. First, we've been doing that at scale before the term MLOps was ever popular enough for us to even know about. So in the first few years of the company and the last, specifically the last 4 years, we've been ingesting and processing over 41 million hours of media. And that rate of ingestion and processing is actually growing. And today we stand on over 1 million hours of media processed every single month. So once this content is ingested, we run over 9 million cognitive tasks in our system every month. Just internalize this number, and let's talk about how we make it happen internally. Processing results are used by over a dozen different applications and many solutions, serving customers across diverse markets, from government to energy, media, and more. The second reason why Veritone is in a unique position for machine learning operations is that we've been working hard on productizing the very same platform that we use internally in order to offer our partners and customers the same depth and breadth of capabilities that we use internally. So my hope is that this talk and the real-world challenges and lessons learned that we will present will help you in your journey setting up the AI stack and the machine learning operation practices in your organization. The best starting point to understand how Veritone views MLOps is by looking at the high-level architecture of aiWARE, and also to understand why we call it an operating system for AI. So aiWARE really starts at the bottom with data ingestion. And data ingestion is done by a variety of different data adapters that can ingest data real-time, not real-time, structured, unstructured, from various different sources. And developers can also add their own adapters to the mix and ingest any form of data. Data is then being processed by over 400, by actually any number of, out of 400 different engines ready to go and available on the platform. And again, we will see later how your organization can use the same tools that we use to deploy your own bespoke models to participate in the same processing. The next layer of aiWARE is controller, and controller is really the heart and soul, I should say, the processing and orchestration system of aiWARE. Controller is all about accepting rules as processing graphs, dynamic hot cyclic graphs, from the API or application layers, and execute those based on specific instructions by running any number, again, of cognitive engines, AI models, and data ingestion at scale. Controller is the piece of aiWARE that abstracts away the actual scaling and operation from the user and from the operator and makes everything seamless. We'll talk about it more as we go along. Now, processing results or metadata produced by AI engines like transcripts, video detections, document topics, and more are then indexed into TED. TED is a temporal elastic database as part of aiWARE. And this is, we can view that as the aiWARE long-term memory. TED allows the higher levels of the stack, API and applications, to perform time-correlated multi-cognitive searches across large corpuses of data. So, fun example, say you wanted to find all the times that Serena Williams said the words US Open in a video interview, and she had a Coca-Cola logo in the background. Right, that becomes, using TED, just a simple sub-second search query by the application layer. So on top of all that sits a robust API, low-code platform that we'll talk about later on, and an application layer. But what are the benefits, and why are we using aiWARE internally, and why do we recommend it for our customers and partners? By using aiWARE, we're able to really innovate much faster and get solutions faster to market. The models and the building blocks available on aiWARE make application development so much faster and more accessible to more people in the organization. The ability to abstract the interface between the application layer and the AI layer makes application development and the application themselves more customizable and more future-proof as requirements change, as we all know, and models improve over time. aiWARE, I should say last, aiWARE lets application developers really focus on delivering the value to their customers rather than operating the underlying components of the applications. Shifting gears to the machine learning, the MLOps process as we see it. So we like to think about it in five topics, or 5 different phases of the process. Deploying the models, integrating them into applications and solutions, scaling them, monitoring various different dimensions, and then complying with different risk characteristics. As you can see down below on the slide, Veritone has developed internally tools to cover one or more aspects of the process. Altogether, those tools cover the majority of that process, and some of the tools are already externalized and available for our customers and partners. We use all of them internally, and we make a real effort to make them available for everyone. Let's dive into the deploy aspect. And this is where we really start talking about the Veritone lessons learned over the years of building machine learning operations and applications. So deploy is all about getting new models and new versions of existing models to production, ideally in a seamless and safe way. If we dive into some of our lessons learned around deploying AI models, it really started for us by the need to democratize deployments. To do so, we really had to build guided tools for model owners to deploy the engines to production. We found over time that empowering data scientists and developers to deploy their own models rather than managing deployments by a central team can really help us move faster and also safer, which is great. There's almost zero trade-off here. Let me show you real quick how the Veritone developer application would enable someone to go ahead and deploy their own model and engine to production on their own. So as you can see, this is a fairly simple wizard. I may choose that my engine complies with object detection category, and we'll see later what that means to be categorized in the system. Maybe this is a segment engine that takes chunks of information. Let's say that we support images and videos of various types. I'm not going to focus on this one, but the testing ability lets the platform validate that the engine run appropriately in a continuous manner. And as we talk about government applications, in many cases, the engines are network isolated and can't reach to the internet. We can pick the name, description, etc. Say the engine is not using any library, and it's meant for find dogs. For whatever reason, that's what I want the engine to do. By deploying that engine, that's it. from that point on, we use Docker technology to upload the model into our registry, and that Docker container can now be versioned and managed by the application, by the platform, I should say, in a seamless way. So this is an example for one of our engines. As you can see, there's plenty of versions. You can version it. You can decide which one is deployed, etc. Let's go back. So as you can see, deploying an engine is fairly simple. It can be done by almost anyone on the IT side of the organization, not by a centralized MLOps team. But over time, one of the learnings that we had in building the deployment product is that we needed a base common familiar technology. This is where we picked Docker as something that if our engineers and data scientists don't already know Docker, there's plenty of available resources, and we could teach them and make it easier for them to use. Over time, as we did it, Docker became even more popular, and now it's a ubiquitous technology that turned out to be a pretty good bet on standardizing deployments. But I think an even more interesting learning that we had is Docker. While Docker was a major step, it wasn't enough, and this is a really hard learned lesson. I have to admit. Over time, we realized that the breadth of engines deployed in aiWARE is actually becoming a huge drag on the ability to innovate and build core platform capabilities. And the reason was, with 400 engines on the platform, every change to the control plane required rigorous testing and backwards compatibility exercises across all the engines. That was massive exercise every time we wanted to improve and innovate on the platform. That's where we borrowed, again, a concept from traditional operating systems and came up with the concept of the engine driver. What the engine driver does is completely abstract the model, the machine learning model, from the Docker technology and from the proprietary orchestration technology, which is controller inside aiWARE. That driver allows models and control plane to innovate separately without breaking each other. That was, again, as I said before, we learned it the hard way, and we're happy to share this learning with you as you're building a robust AI platform. Now we have those engine drivers deployed, and we see a significant benefit by being able to innovate faster on both sides. Then the last aspect of how we over time standardize deployments is by using a standard interface. So as you saw before, when I chose object detection, I believe was the choice for the engine, then all of the object detection engines actually comply to the same standard, which means that they are all available for indexing automatically, so the engine developer doesn't need to do anything. They're able, users can search across all the object detection engines, regardless of the model implementation. And even more interestingly, they are completely comparable between each other. And we'll see later how we benefit from this capability down the line when we think about compliance and monitoring. So, great. We have models now deployed in production. But how do we think about integrating them into different applications, business processes, and et cetera? So the way we think about it is using a simple schema. Any type of application, be it RPA, line of business, custom products, they would trigger ingestion that would then go into aiWARE using either low code or API, trigger a series of enrichment steps, which is basically running AI models in a certain order using the processing graph that I mentioned before. And then results will be infused back into the application via, again, API search capabilities, or low-code connectors. That simple integration schema turns out to be pretty powerful across different types of applications and machine learning models. And over time, we developed a lot of gotchas and takeaways that I wanted to share today. So starting from standardization, again, going back to taking the approach of integrating AI into the business processes and systems in a standard way. So if you run multiple models on the same platform, and those models are supposed to interact with applications in different ways, it is advised to come up with a standard interface that will then help you replace or swap that models if they become obsolete, or even customize your integrations to choose one model over the other for a specific use case or a specific customer without making any significant changes to the application layer. This approach was huge for us as we realized the level of customization that users need and the level of changes in the market as it relates to models becoming better and better over time and become better than the existing model. Now, you can never assume that a use case for an application can be solved by a single engine. So the ability to group all those models together in a single package is extremely important, and I'll show you how the developer application in Veritone is doing that. And lastly, when we thought about integrations a few years back, we mostly focused on how do we build a UI or build a product that's using the models under the covers. Then over time, we opened to integrating AI into more and more existing processes, existing systems, and existing applications used by our customers and partners. We still consider every time if we want to integrate to an existing system or build a new application, but now it's more of a business decision that has to be made versus a technical limitation or a technical decision by the IT team. That is allowing us to meet the customers where they are, as opposed to convincing them all the time to move to different applications and processes. So just a brief kind of screenshot of how a single application might look like as 7 different models are being integrated into it. And you can see that we can version them, we can replace them, and we can have them collaborate to perform a single, to really back a single application. This application in particular is a video evidence reduction application that's using 7 different models. When we started marketing those applications, we had 3 different models, and now we have 7. So over time, we seamlessly added capabilities for our customers with very little effort by the application team. Let's move to the next one, which we have models and applications integrated, but it turns out that scaling them in production is a fairly tough problem. So what I try to do here is to recommend how to think about the scaling strategy in 3 different dimensions. One, the first dimension is what we call slow scale. And slow scaling is the ability to make your infrastructure scale with no developer or operator involved when the business and usage grows over time. You can think about it even in shorter cycles, like how do I scale my operations over a day or a week or even over a year with seasonal changes, or when the business grows. So those are baked-in capabilities that we have in aiWARE to detect when the system needs to scale up or down, and then interact directly with the underlying infrastructure to add or release resources as needed. The second aspect of the scaling strategy is the ability to run any number of instances of the same model in order to process more data and faster. So in one of our applications back about 2 years ago, we realized that the user experience is actually much improved if we chunk the video into frames and process a large number of them in parallel using multiple instances of the same engine. Now, that capability is inherent and baked into how aiWARE and controller operates, but without that capability baked into the platform, it would have been a fairly difficult task for an application layer to perform and to be able to control the parallel scaling of the engines. So this is an important aspect to think about as you think about scaling, how to scale in parallel, horizontally. The third aspect is about optimizing the processing cluster. And we found that the cellular architecture works best for us. So controller and aiWARE is able to stand up and down standalone cluster for processing. We call them cells. That can then send data back to central location. And that lets us tweak the specific clusters in the best way possible for cost efficiency and performance. Now, at the end of the day, scaling turns out to be a complicated business, especially if you're looking for cost efficiency in your operation. By making some deep architectural changes, the ones we discussed above, Veritone actually managed to reduce the specific type of processing cost by over 30 to 35% in 2020 without reducing the load. So, and how did we do that was actually surprising to me personally. And the main contributor to being able to reduce cost was actually focusing elsewhere, focusing on resiliency. And the resiliency, we all know that it's super important for the stability and the performance of the system, the user experience, etc. But it turns out that when the system is as resilient as some of the services in aiWARE, we could run them at almost 100% CPU utilization. Now, for me, it was an abomination. Running 100% CPU utilization seemed terrible. But when you build a system that's as reliable and can recover from almost anything, including spot instances being taken away, etc., that really lets you run at maximum utilization and save costs. Next, after scaling, is, of course, monitoring. And this is something that, again, we invested a lot in getting extreme visibility into the operations. Here on the screen, you can see one specific cluster, one production cluster out of many. So I chose this one because it had a different, it had an interesting pattern yesterday, where if you look at it for a day, you can see that around 11:18, for whatever reason, a backlog started building up in the system. And you can see down at the bottom, the running engines, how the system reacted autonomously, completely, by scaling up significantly to almost 6,000, the number of running instances of the same engine, and started eating through the backlog until it was gone. So this is an example of extreme visibility on the one hand, but also automated operations on the other hand, done by AI. Here we can see, I'm not going to focus too much on that, but we can see the various dashboards for running tasks in the system. This is for one day, and you can see over 500,000 tasks running at any time. This cluster is used for development as well as production, so you can see a bunch of errors coming out of the of the models themselves, and we have other tools for logging and error monitoring, etc. The last graph that I want to show is more on the infrastructure level, and you can see how the number of hosts, infrastructure, virtual machines, Linux machines, scale up and down, and sometimes even deep. This is probably due to spot instances being taken away. And that is done completely autonomously and automatically by the platform as the scale the processing requires. Moving on to the next item on the list, which is compliance. When we have models now running in production, we have applications, we know how to scale them and even monitor them. But one of the challenges of AI is that sometimes we can be exposed to various risks that we don't really have visibility into. Like, is the engine or the model not accurate enough right now? Has the accuracy drifted? Maybe it's introducing bias or vulnerability. And the key point is the somewhat obvious statement that if you can't measure it, you can't improve it. And this is where we spend a lot of time using our VTN standard for input and output to build an application or product, as well as a process that can compare engines to one another, as well as to ground truth data, and create a unified scorecard for every type of AI or cognition. So this is an extremely powerful product that is now in beta. It's called Veritone Clarity. I'm not going to focus on this one. My colleague Gus Walker gave a fantastic talk about building trust in your AI yesterday. So if this topic is near and dear to your heart, I encourage you to go ahead and take a look. The last piece of advice around compliance is really building your system in a way that can be deployed on any generic infrastructure. We in Veritone went kind of the other way around. We were born in the cloud, and then over time we became completely agnostic to the cloud provider and environment. Now aiWARE can run on any Linux-based machines, and as a result of that, we were able to scale to various cloud providers, get different certifications, different geographies, which is important for compliance, as well as going on-premise, which is oftentimes as well a key component of keeping your operation risk-free or reduced with reduced risk. All right, shifting gears a little bit to low code, and up until this point, we covered the various aspects of machine learning operations and how we can improve them and what best practices and lessons learned we gathered in Veritone. But now, nowadays, the biggest, I think, evolution or revolution happening around dropping the time to market and the effort and the cost of building new machine learning workflows, models, and applications. And for that, we built first internally and then recently brought to market a product called Automate Studio, which is pre-integrated with all of the AI models in aiWARE, as well as all the features and capability of the platform, but is introducing, instead of a developer API, it's introducing a low-code drag-and-drop platform that allows rapid development by more people in the organization, citizen developers, citizen data scientists. And what's nice about Automate is that once the workflow is defined and it's working as a prototype, scaling that up is a zero-click operation, which means that all you need to do in order to scale up the same workflow is to just literally throw more data at it. It is also community supported, which allows integrations, as I mentioned before, into existing line of business applications with the customer organization. So let's look at the time. The interest of time, it's kind of hard to pick which flow to demo, but I wanted to choose one and kind of go over it. Really, if you think about it, the capabilities and the opportunities for what you could build with Automate Studio are limitless. And here I chose to show an NLP, a text-based workflow that was built in under 2 days. We built it as a proof of concept, but again, if we wanted to run it in production, it would be just a matter of running that with more data. So what this process does is pretty cool. It would scrape the web for different company earnings data for today, and we can run it every day, or we can run it over a period of time. It would go and scrape the web, find which companies exceeded expectations, analyst expectations, which ones are below expectation. It would go then into the company description, again, all automatically from the web. It will do keyword extraction and try to analyze what those companies are talking about in their description. And then if I run it, in just a matter of seconds, I will get all the results at the side, and I'm going to get an email with a CSV in this case, showing the different performance metrics based on an NLP analysis. Now, what's cool about that is, what if we wanted to also add, let's say, sentiment analysis to the same flow? So let's do sentiment, and in this particular cluster, these are the options that I have. And in sentiment, in this particular cluster, I only have the Microsoft engine, but I could add others. And then instead of using that link, I could go connect it to sentiment analysis and continue the process. If I had data coming from audio or video, I could then append it and build more and more capabilities into the platform. Again, deployment is literally done. What I did right now is deploying the engine to production, and I can run any amount of data through it. In this case, just running it today, I added those graphs before the call. And interestingly, companies exceeding expectations are talking about medicine and all those other topics. But that's, I guess, beyond the goal of this conversation. Going back to what, so that was just a fun demo that we built to show you guys what Automate can do in a very easy and quick way. Again, possibilities are limitless, was how to choose which one, but you can imagine what you can do with it. And I'm actually excited to see what everyone can do with Automate. So we open it up for signups. We allow people to get credits and even get paid as they build flows and put them in the public library. Go ahead and give it a shot. It's worth it, and we would love to hear your feedback and what you built with it. And now I am excited to hand it over to Dave, who is going to talk about the super critical aspect of integrating data into the machine learning operations cycle. Dave, take it away.
Awesome. Thanks, Kafir. Kafir, if we could go, Kafir's going to actually run the slides here for me. So I will kind of kick it off from there. Yeah, so as Kafir mentioned, my name's Dave Cook. I work for Figure 8 Federal. I'm a senior director there and the lead AI scientist. If we can go right into slide 2, or the next slide, rather. So I wanted to start off with a quote, but also a question. And I want this to be directed towards the audience. This is obviously something we can ask at the end, or you can answer at the end. But how many of you in the audience, I want you to think about, are data entrepreneurs? And, you know, think about that. Think about it not only in terms of, you know, are you a data entrepreneur, but what is a data entrepreneur? And to me, someone who's a data entrepreneur is someone who, through either tools or tech or methods, helps uncover truth and meaning in data. They help find and help others continue to find value through software and through data. And I've been working in the federal government for over 25 years on data, on analytics, on GON, and now machine learning. And we have really never been at a more critical inflection point for data entrepreneurship with the advent of AI and ML as it's coming into its own within the work that I do on the federal government. And that's among companies that are large and small, among individuals from data engineers to AI ML engineers to DevSecOps engineers to data scientists and analysts. You know, and what's critical within data entrepreneurship, what's critical for all entrepreneurs, is the ability to produce something of value. And that's really the point of my first quote as I'm kicking this off. It's something that I actually took from my colleague, Lucas Bewald, which says, those who do not track training are doomed to repeat it. And what Lucas is talking about here is reproducibility, which is a huge issue in machine learning. Really simplified, can we trust ML models at all? And I kept Lucas's quote in mind as I put together my talk, walking it back a bit further to think not just about model training, but really to the very core of ML, to data. You know, data is the fuel of machine learning, and it's not something that you can really afford to get wrong. That's why I have the second quote, that those who do not manage data proactively through engineering, through infrastructure, through experience, and through best practices are really doomed to obsolescence. It's not just failure, but obsolescence. You may get started, but if you don't really think through and work through data at scale, you'll make mistakes that are either costly or you'll develop prototypes that will never get out of the lab. You have to take a real data first, a data ops approach to produce and even begin to reproduce ML for the real world. So if we go to the next slide, I'll tell you quickly about who we are, who Figure 8 is. So Figure 8 Federal is a DC-based company, but we've got Silicon Valley roots. We are a company that focuses on the federal government solely. In particular, most of our work has been within the DoD and the intelligence community. We focus in on supporting scalable DevOps through deep experience with leading DoD, federal and commercial entities, working on a number of different use cases. So whether you're talking about computer vision, or you're talking about data classification, or you're talking about things like JADC2, Joint All-Domain Command and Control, or Health and Human Services, we support DevSecOps and have deep experience in all of those. We really enable AI ML at scale with expertise in data processing and pipeline automation. We have partnerships with industry leaders in machine learning model T&E, benchmarking, and model refresh. And then we have a platform. We have a platform and human-in-the-loop annotators. You need both. And we provide a platform that allows for data annotation at scale. We work both in the unclassified domain and the classified domain, and have human-in-the-loop annotators that also can work from FOUO, office use only, or unclassified data, all the way up to TSSCI. I like to say that, quite frankly, if you have have a phone, or have a personal assistant in your home, or you have a nav system in your car, chances are you're using machine learning capabilities that were trained off of data that we provided. Can we go to the next slide? So one of the key lessons that I found really on working on Pathfinder programs in AI and machine learning, is that you begin with data automation in mind. And what you're going to see in a couple of the slides that I have here, I do want to get ahead to the questions because those are usually the most informative, but I try to put together a couple of lessons to think about really best practices, things that you should think about when you're really pursuing data initiative. And one of the things that I really focused in on is data ops. Every time that you're taking on the idea of how am I going to have an AI and ML program, the thing that you really need to focus in on is what's your data strategy? How are you going to do that? That's the first thing whenever I'm working with a government customer, whether I'm working with any customer, is tell me about what your data acquisition strategy really is and how are we going to work with that. And so one of the things that I try and focus in on and help others focus in on is data ops. A data ops is really a data management method that emphasizes communication, collaboration, integration, automation. It has a measurement of cooperation between data engineers, between data scientists, and other data professionals. So you're really getting all these different groups brought together. And I borrowed the quote from Andy Palmer of Tamer, who really coined the term in his blog post back in 2015. But you can see at the end of this, he really gets into a key element of what data ops is all about. And you can see at the bottom, it says delivering data from many data sources to many users reliably with a provenance required to support reproducible data flows. It's about reproducibility. It's about, can you produce with data, and can you reproduce things with data? Are you able to track data as it moves from acquisition, where it's created, and acquisition and ingest, all the way up through the stack to where it's training a machine learning model, it's being deployed, and then it's being used to retrain. You have to have communication and collaboration across all of those different elements. And you have to think about, how am I going to automate that process of data as it moves through software and ultimately moves out to the real world. If we go to the next slide. So if we go from data ops, how do we really get into data pipelines? How do we go from managing many data sources and many data pipelines with a wide variety of transformations? So what I've tried to dive into here really is, what does an ideal pipeline look like? And pipelines are critical, so let's really talk about them. Key to machine learning ops is the ability to support a well-defined AI/ML problem. And this is one of the things that you see if you look up into the far left of the screen. You can see where we start off with, what does a solid AI/ML pipeline really look like, and what does it look like to really frame a problem? And this includes things like defining the needed data sets, identifying and defining the ontologies, and how do we really work with both data acquisition and metadata acquisition. One of the first key elements that you'll see, within this overall kind of high-level pipeline solution that we're talking about is something that we focus on at Figure 8 Federal, which is, it's your data. Data should really remain at rest. It should be distributed, and it should be able to remain at rest. You should be able to link to data without necessarily having to ingest it. That's one of those critical components, because the lift and the shift of moving data around can result in corruption, can result in problems with provenance. And quite frankly, you shouldn't be providing, data, or a customer shouldn't be providing data to an industry partner, a commercial customer, or a commercial client necessarily, in order to have them be able to build products off of that data that they can then sell back. It's a best practice to really have data be able to remain at rest and not be ingested. So if we go from the far left of the screen here, you can see where we've got data initially being ingested, and it's either multidimensional data, it can be different kinds of multi-int data. But what we've got in the first steps as we move from left all the way to the far right is the initial data card creations within this pipeline. You've got an operator, really creating that data card, so that there's a data ingest and a job creation of a data annotation task using an API. And this is a very loosely coupled pipeline integration. So all of the capabilities are plugged in via API. There's not necessarily anything here that is requiring more than those API those API connections. But as we take that data at rest, you're able to retain that provenance. You're able to put firewall around it and really be able to control it by a number of different elements that you need. As we go from the data card creation, we go into the second step, which is really using the data management platform. You have an API or a UI that can launch the data annotation task. And you can see here we're launching the Figure 8's platform. But that data annotation task really allows for that data to be labeled at scale. And you've got the ability to automate this entire process. So the data annotation task is being kicked off automatically, going out and is creating that training data set. From there, we go really into the next step, all being automated, where we're allowing for the data to be picked up by AI/ML engineers from the DMP. From there, we go from the DMP has the API, the UPI that's pushing the machine learning model for testing and evaluation. And one of the real best practices that we see with the data pipeline is the ability to have a secure model repository or a secure model enclave where you can do model benchmarking, you can have model governance, you can have data set validation, you can have selective sampling. You have the ability really to commingle a wide variety of data sets to be able to run multiple model tests and to be able to reproduce those model steps. From there, we go into the data set and the model variation that's continuing as we go into step 5. And then finally, you go back to the machine learning model deployment, which can be for a single, it could be for a multi-int use case. I'm speaking of DoD in this use case. But what we've got is going from step 1 all the way to step 6, whether you're talking about a single data pipeline or multiple data pipelines, you're really able to work very effectively in getting those machine learning models trained. Can we go on to the next slide, please? So from here, what we're looking at is a framework that we really designed in order to incorporate a pipeline approach. And what you can see within this approach is really, a very comprehensive way in which you're able to integrate both open source and best-in-class COTS capabilities at each level of a stack. There need to be a number of different things that go into how successful AI and ML is deployed. And you have both a combination of technology and process. They're both required. They both have to work together. And what we've tried to create in our approach is really a set of building blocks, stacks, or foundations. That's what you really see here. We've taken a look at, many different infrastructure solutions, really understanding that with AI and ML, you need to create a base infrastructure that'll allow you to grow into your solution. And your infrastructure really, though, is not what you're normally building, but it's something that you really have to account for. And what you see here, if we look into the diagram, are a number of different stacks. Think of them like building blocks that we're recommending that people need in order to be able to plug together and get AI fully operationalized. So you can see at the bottom, we push for an infrastructure stack where you've got infrastructure and security as code. We're working on top of all different kinds of cloud infrastructure, and we can easily accommodate a hybrid infrastructure. You've got your security stack above that, with infrastructure and security as code, applying things like GitOps and Terraform. You have your database pipeline using a distributed database. And then you have your AI training and development, as well as your AI deployment and retraining. And then we provide an operator, a UI and API layer at the top. This is something that we really feel allows you to be able to add on as many capabilities as you need and really be able to work effectively when you're trying to think about how you're going to deploy AI and ML effectively using data. If we go on to the next slide. So in the next slide, one of the things that we also really want to encourage as a best practice, to allow people to account for, is distributed data. And in particular, this is whether you're working in a single data center or multiple data centers, how are you going to be able to deploy and work with capabilities? How are you going to be able to work with AI and ML? Data, it's something that you really have to account for, whether you're thinking about a single or a multiple location deployment. We're designed really to try and make AI and ML accessible to the end user. And at a high level, you can see the different ways in which we're moving through the pipeline once again with data processing, data labeling, and AI training, AI development, and then AI deployment. And we're all using a virtual object store, which you can see right in the middle of the slide with metadata tracking, that allows you to have a number of different instances or work across a number of different instances of data centers. If we go to the next slide. Now, in this slide, this is really what we're looking at overall, is what does the framework look like for deployment of AI and ML? And in this case, what we've seen is what we call SIRE, which is a configurable, iterable, repeatable, and extensible framework that allows you to build, maintain, and advance capabilities across AI and ML across different kinds of customers. But you can see we've applied here a hub and spoke approach that allows for data processing, data training, AI development, and AI deployment across a number of different use cases, and really allows you to put in something in place that's going to help AI scale overall and support MLOps. These are things that get questions quite often. Is this something that is necessarily sold? Is it a complete comprehensive framework? And the answer is no. What this is a framework that you can plug in as many capabilities as you need, because if there's something that we know about data and about data ops across our different customers who are really working at massive scale, is that everything is really nuanced, and so you need a lot of flexibility built into your approach, and that's what we've tried to do here. We go on to the next slide. And that's it for my discussion around data. I put a couple of things in here about how to reach out to me, but what we're really interested in, I think, is your questions and what we can answer.
Yeah, I want to thank you both for that presentation. That was great. And I know that this was really about MLOps done right, but I want to take a step back, because I know that you gave a great presentation. But when you're talking to customers and potential, users, do they have an understanding of what MLOps is? And are you explaining kind of how things work? I know that it's fairly new, so and we do have a very broad range of people that are attending this conference, and I know that you talk to as well. So I kind of wanted to just level set there and say, when you are talking to people these days, do they have an understanding of what it is, or do you find that you're also educating them on that and then digging deeper?
I'll be happy to jump in there. I think that within AI and ML, it is a constantly iterative process, and it is a constant education. And that is not impugning in any way any customer or anybody that we're working with. There are always new technologies and tools. There's a lot of rapid innovation. So I do find that it is very much an education process. I'll also say that my experience, doing this for 3 years, working with the DoD, I think early on and even to this day, we learn as much from them as they learn from us. And so it's very interactive and collaborative. People are bringing us new data and new use cases, and we're usually sitting down and saying, okay, I think we can work with that. This is what you want to do. This is what we think we can do. And this is how we're going to kind of meet in the middle. So it is very collaborative. In some ways, I think it's symbiotic.
Yeah, and I would definitely agree. I think what's one of the things that's really fun about AI and MLOps right now is that various customers and various organizations are in very different stages of implementation or even understanding what that means for them, right? So we meet customers across the spectrum. Some are very much educated and know what they need and come for solutions. But we also meet a lot of customers who understand the problem space, their own needs for AI, but now they're looking for the best practices and the tools to make that happen in the organization. And I would add to that big part of the education kind of process and engagement is about looking a little bit into the future. So one of the things that's very concerning for people adopting AI and MLOps is, how is it going to look like in 6 months from now or 5 years from now? How do I mitigate risks and take the right approaches and decisions now, not to be kind of hamstrung by that in the future, which, as everything you do for the first time, this is always a little bit of a risk taking and scary.
Yeah. And you guys brought up throughout this presentation that this is ever evolving, right? And, things of 6 months ago change and all that. So, and I know that we've been talking about best practices and how to do it right. So for people that are either just starting or have started, what are some best practices that you've seen that you can share for people to really get set up for success?
Yeah, happy to jump on that one. When you really just get started, we always there's plenty of good advices out there. So I'm not going to cover all of them. Some of them come from Cognilytica as a really great kind of trusted consultant. But what I like to talk to customers about is rapid prototyping. So get to a point where you can very quickly see what you imagine working with the real data and the real systems that you need to be integrated with, and then deliver bespoke solutions by choosing the right POCs, proof of concepts, and prototypes that really turned out to be the right ones. So rather than keep contemplating and thinking about what would be the right thing to build and how to build that, go ahead and quickly and rapidly prototype and make an informed decision after you do so.
That's great.
I'll just add real quickly there. There are 3 questions that I always ask that I think that help define what the best practice is. And for me, it's always when I'm working with a customer, tell me a little bit about what your data is. Help me understand what you're trying to do, which is usually your ontology, and then what does success look like? Think about those 3 things, because that's going to help define what the data, what other models, what all of these things. It will not take you down the rabbit hole of, I want to do everything, or I just want to do AI, or I want 10 different models. And it's like, let's focus in on a couple of key things.
Yeah, I think that's great to focus too. And, the reason I brought up my first question was that at Cognilytica, we are a research and advisory firm. And so we have produced for the past few years reports on data labeling and data preparation. And the amount of evolution that has occurred in just those few years is incredible. And then we did an additional report on MLOps and, the companies that are emerging, how people are addressing things. We've really seen an evolution. And so that's kind of why I wanted to ask you, are you educating customers on what this is, or do they already know what it is? Because we've seen a lot of things come up about MLOps recently. And so like with everything, it's evolving, which is wonderful to see. But that's why sometimes, it's nice that you can move along with your customers kind of at the same time in that journey, or sometimes you're just a little bit ahead. And then, like you guys said, things do change so rapidly.
Yep.
So that's great to see. Now, I know that we are a little over, but your presentation was so good. I didn't want to stop you guys. Do you have any, parting words of advice for people that are watching this? What they should really focus on? Maybe we had talked about lessons learned, but if you have like a use case that you want to share, if it's very fast, or just some parting words of advice.
Sure. So I would encourage folks again to exactly what I had said about thinking through those three questions. What is your data, and think about what that data really is. What is what is it you're trying to really do, and then understand what success really looks like, because those are going to really drive towards towards ultimate success. And think through. As you're going down that road of models, you will find that you will work your way back to data. So, make sure that you're thinking about throughout, your entire project.
So I completely agree. We try to give, I think Dave and I have a number of very specific best practices and things to kind of think about in the process. But I would say at the highest level, I think if you want to be successful in MLOps, first of all, you have to acknowledge that this is a thing, right? And this is something that happened in various other practices in the past, where it starts as something that coupled together with, let's say, process automation or model development, data science, and then once this gets decoupled and the organization gets really good at that, and think about it as its own set of problems and challenges, that's where you can start adopting both tools, best practices, lessons learned, find the right people to run this for you, and be successful in this space.
All right. Well, that was great. So thank you guys. I know I put you on the spot a little with last words, but the presentation was incredible. And I, encourage people to, if they've attended this live, to rewatch it. And then for folks that were not able to attend this live, to rewatch it, because there really was a lot of really good information in there. I know some of those slides were very visual with things that I would like to go back and look at in more detail. So I'm sure others will as well. So thank you so much, and have a great rest of the day. And we will see everybody for the conference back here tomorrow at 9 a.m. Eastern.
Thanks, everyone.
Thank you.